Hi friends, I am Rohit Agarwal and I welcome you all to this live session presented by TalentSprint's Banker's Choice program. In this session today, we are going to discuss a very important topic from the Quantitative Aptitude section of the SBI Clerks exam. And this topic is simplifications. Well, the name says simplifications, but it seems to have brought complications to the life of many of the bank exam aspirants because they generally find it difficult to solve questions from this topic of simplifications. But believe me, if you have the right approach, this is one of the easiest topics and it can become your score booster in the exam. The weightage of this topic in the SBI Clerks exam is anywhere between 10 to 15 marks. So you get 10 to 15 questions on pure simplifications. Well, in one way, if you really look at it, all the 50 questions from quantitative aptitude are based on simplifications. Whether the question is from time and work or profit and loss or percentages or data interpretation, right? You just name any topic from quant, there is some sort of simplification which has to be done to arrive at the right answer. So in one way, all the 50 questions from quant are based on simplifications. But as such, if you look at pure simplifications questions, where simply numbers with different arithmetic operations are to be done, we get about 10 to 15 of them. So this becomes one of the most important and high weightage topics in the quant section of SBI Clerks exam and the various other banks exam as well. So we are going to look at this topic and some of the smart ways of answering questions from this topic of simplifications. Now, what do you mean by simplifications? It is a process of performing various kinds of arithmetic operations to arrive at the right answer, right? One equation is given to you, which has got different arithmetic operations like divisions, multiplications, additions, subtractions, and some exponential orders like squares, square roots, etc. We need to solve all these parts, simplify the equation, and arrive at a simple answer, simple number, which is the correct answer there. Now, the most important aspect of solving a question on simplification is the order of operations, right? How do you proceed towards solving this question? What is the first operation that you perform, or what is the second one that you need to look at, right? You simply cannot start working from left to right or the way you want, right? There is a proper hierarchy that you need to follow while solving questions from simplifications. And this can be understood using a very important rule called bodmas rule, right? So let's first look at what is meant by bodmas rule, and then we'll look at some questions from simplifications. I'm sure all of you are aware of this concept of bodmas principle, right? It is called differently in different parts of the world, but then it's all same, right? Whether you call it bodmas or if you go to the US, they call it as pedmas, right? Pedmas or pidmas, whatever it is, right? The process is same. The hierarchy remains the same. And this talks about what is the hierarchy that you need to follow for solving a question on simplification. Which operation should be done first, then which operation should be done second, and so on, so that you get the accurate answer, right? What I'm trying to explain here you is something like this. For example, let's say we have a simple equation 3 into or I would say 3 plus 2 into 6. 3 plus 2 into 6. Now what do you do here? There is one addition, that is one operation. The second operation is multiplication. Now how do you simplify this? What is the correct answer? Can you say 3 plus 2, 5, 5 into 6, 30? Okay, that may be one answer. And if you look at multiplication first, if you do multiplication first, what happens? 2 into 6, 12. 12 plus 3, 15. Now look at the two different answers, right? One equation cannot have two different answers, right? There should be only one correct answer. Now which one is correct here? Is it 30 or 15? 15 is the correct answer because this follows the bodmas rule which I was talking about, right? Let's understand what is meant by this, and then again we look at the simple equation to see how does it help us in getting the required answer. Now this is actually an abbreviation, right? Each letter here stands for one term. For example, B stands for brackets. B is brackets. Let me just give the abbreviation first. B is for brackets. O is for off, or you can say other operations, or it is also called as orders, etc. Right? Basically multiplication, one kind of multiplication. D is for division. M is multiplication. A is addition, and this is subtraction. So this is the hierarchy that we need to follow from left to right. If you look at it, the first term is brackets, then comes off, which is multiplication or other kinds of operations. Now this includes, finding out squares or finding out cubes, square roots, cube roots, etc. Then followed by division, multiplication, addition, and subtraction. So as per this rule, when you look at an equation or when you look at a simplification based question, you first need to simplify the bracketed part. Whatever comes within the brackets, that has to be simplified first, right? So that's what is meant by brackets, right? Whatever is inside the brackets, first simplify that part. Then after doing that, we need to look at the other operations, the orders, right? As I've mentioned, square roots, of, for example, sometimes you see 3 by 8 of 16 plus something, right? So of here is nothing but one kind of multiplication. So that's what we need to look at after performing the, after simplifying the bracketed part. Then once this other operations are done, the exponential operations are done, you need to look at divisions, right? If at all there is a division in the equation, do that division first. Then followed by multiplication, additions, and subtraction. So that's the order which you need to follow. BODMAS, bodmas rule. Now, if you remember, I was talking about other rules in different parts of the. For example, the same thing is also called as PEDMAS, right? PEDMAS, right? Basically, when you understand, I mean, when you go to the US, they don't really call it BODMAS. They say PEDMAS. Now, there's not really a difference in these two. B for us is brackets, whereas P in PEDMAS is for parentheses. Brackets is also called as parentheses, right? So they call it parentheses. Likewise, O is order, other operations, of, right? E is exponential, right? They say exponential. Whatever is in the form of exponents, that has to be simplified. So which includes squares, cubes, square roots, powers, right? All orders. Then D and AS, or sometimes it's called as PIDMAS, PIDMAS. I there is indices, right? So parentheses, indices, division, multiplication, addition, and subtraction. So more or less, it's all same, right? Only the name differs because we call brackets, they call it parentheses. So don't get surprised if at all you find something called as PEDMAS or PIDMAS, while solving these questions somewhere, right? So it's all about following this hierarchy while solving the questions from simplifications. Now, before we actually look at some of the questions here, other important point which I would like to mention is this D and M. Understand, as per the rule, division first, then multiplications. But then divisions and multiplications are similar operations, yes or no? Multiplication is kind of division, one kind of division, or I can say division is one kind of multiplication. Are you able to follow? 2 into 2, that's a multiplication. 2 is getting multiplied by 2. 2 is getting multiplied by 2. Or if you look at it the other way, 2 into 2 is multiplication. This is a simple multiplication. Or otherwise, can I take it as 2 divided by 1 by 2? This also becomes 2 into 2. 2 when divided by 1 by 2 will give you 2 into 2. So if you really look at it, what is multiplication is one way a division, or what is a division in another way can also be called as multiplication. Same thing happens for additions and subtractions, right? Subtraction is a kind of addition, right? Instead of saying that I'm subtracting 2 from 6, I can say I'm adding minus 2 to 6. Are you able to follow? Instead of looking at it as subtraction, we can say this is one kind of addition where we are adding a negative number to 6, right? So the point which I'm trying to mention here, or the point which I'm trying to make here, is that divisions and multiplications are kind of similar. I mean, there's no preference as such, right? Likewise, additions and subtractions are also similar. So in an equation, in a given simplification question, when only multiplications and divisions are left out, you can simply move from left to right without worrying about divisions first or multiplications first. Just keep moving from left to right, whichever comes first, keep doing that and you'll get the right answer, right? Remember, left to right, not right to left. Fine. Likewise, additions and subtractions. When you're only left out with additions and subtractions, in that case, you can do any one first, right? You can either go for subtractions or you can go for additions, or just move from left to right. You will get the same answer there, the correct answer at the end of the simplification, right? So this is what you need to understand. That's the basic concept which you need to follow for solving questions from simplifications. And not only simplifications, I would say, you take any other topic. As I've mentioned, each and every topic from quant has got some or other simplification part. This is quantitative aptitude, right? So aptitude based on quantities, right? Numbers. We have to play with numbers in each and every question. So some sort of simplification is going to be there. Be it easy or difficult, it's always there in each and every question of quant, right? So very, very important, not only for these 10-15 questions that you get, but also for the remaining questions. So this is very important again. Bodmas rule is what we follow, mathematics. And not only mathematics again, you take science, technology, I mean everywhere, physics, this rule is followed, right? Because simplification is there in every part of education, so it's always followed, right? This particular rule is always followed. So let's look at the application of this rule now. Now let's take the same example. I said that 15 is the correct answer. 3 plus 2 into 6 equals to 15. Why 15 is correct? Why not 30? Why can't it be 30? Why is 30 wrong here? Because if you take 30 as the answer, you're going against the rule. Look at the equation, 3 plus 2 into 6, right? Addition and multiplication. If you look at the rule, what comes first? Is it multiplication or addition? Multiplication comes first. So we need to look at the multiplication part, right? So 2 into 6, this has to be performed first. 2 into 6 is 12. Then you go for addition. So 12 plus 3 gives you 15, right? How do you get 30? You are adding first. 3 plus 2, 5. 5 into 6, 30. But addition should not be done before multiplication. Multiplication has to be done before you go for addition. So that is the reason 30 is going against the basic bodmas principle there. Right? If at all, I mean, for the same equation, the correct answer may be 30, but with a slight change in the equation. If at all, this is given in this way, let's say 3 plus 2 within brackets, within parentheses, multiplied by 6. Now in this case, if you look at it, 3 plus 2 into 6, same operations, similar operations, addition and multiplication. But then the rule says first go for the bracketed part, right? If you look at multiplication and addition, we'll generally do multiplication first, then we'll go for addition. But then because 3 plus 2, because this addition is within the brackets, you need to simplify this part because brackets come first, right? Bracketed part has to be simplified first. Now in this case, 3 plus 2 is 5. 5 into 6, 30 would be the correct answer. So you have to be really very careful. One small mistake here will give you a completely different answer, right? So first add and then multiply if that addition part is within the brackets. So that's the application of bodmas. While solving a few questions from the Banker's Choice workbook, we'll look at the application of this. Anyway, every question has to be done using this principle, right? So that's a basic introduction for simplifications. Now it all depends on how quickly can you do these calculations. Basically, additions, subtractions, multiplications, divisions, etc. Right? Like in the last session, which we had last Wednesday, we had covered speed maths. We have discussed some aspects of speed maths where different multiplication techniques were covered, right? Then how to find out square, how do you get square roots, cube roots, etc. Right? Speed maths is very, very important, I mean, for solving these questions, because I mean, it all depends on how quickly can you do these multiplications, right? Simple multiplications, 2-digit multiplications, 2-digit additions, subtractions. If you can do these faster, these kind of calculations faster, you will get the right answer faster. So practice more on your calculations. This is really going to be very, very helpful, not only in this topic, but the complete quant section of your exam. So let's get started. I have the part of Banker's Choice workbook here, which has got questions on simplifications. Now I assume that not everyone there on the other side will have this workbook, so I'll write the question on the board for you guys. We'll try to take as many questions as we can in the next 45 minutes because the session has to close by close within 1 hour. So I'll just keep the question here on the board with the options. I'll give you 30-45 seconds for each of these questions. Once you do it, then we'll look at the solution for the one. So I would like to start with a very simple one, something which involves only additions and subtractions, right? Let's look at that. Additions and subtractions, simple calculation. Look at this one. The question says 38.734 plus 8.638 minus 5.19 equals to what? And the options here are 41.971. Second option is 42.179. The third one is 43.072. Fourth one says it has to be 42.182. And the fifth one is none of these. Right? The fifth option here is none of this. So the question is 38.734 plus 8.638 minus 5.19 equals to what? And first option is 41.971, 42.179, 43.072, 42.182, and the fifth one none of this. Generally, as I said, fifth option is always given as none of this, right? So though you have to be, consider this option as well, but then in some cases I would mention, I mean, when we proceed towards other questions, I would really explain you. I would explain you how do you actually neglect this option in some of the cases. It again depends on the situation of the exam, right? So I think 30-45 seconds should be sufficient. Your time starts now. I'll catch you back after 45 seconds. Let's see how many of you get it right. And please do not use calculators because that's not allowed in the exam. All right. So answers coming in. Sirisha says it should be 42.182, fourth option, right? Then we have Omkar has got right answer. Right answer as in some answer, 42.182. Ramana Reddy, Pankaj, Satvik Joy. Who else? Adi Ganesh. Right, and maybe I've missed some names because the chat just scrolls down when more and more answers coming. But seems like most of you have got 42.182. Varsha Chaurasia, she says 43.182. 43.182 is not there in the options. So which means she has got fifth option as the answer there, right? 43.182. Rama, and now Varsha has changed the answer. She says now it's 42.182. But let me tell you, this is not allowed in the exam. I mean, there you don't get the second chance. You just solve it once and mark the right answer. All right, so seems like most of you have got the same answer. So maybe that's the correct one, 42.182. Let's look at the solution for this question. Now, how do you generally solve this? We write the numbers one above the other, right? One upon the other, and try to simplify that part. Or I mean, going by the bodmas rule, you know, it has got addition and one subtraction. So either you can go for the rule that is add first and then subtract, or as I've mentioned, addition and subtractions are similar kind of operations. So whether you do subtraction first or addition doesn't really matter. I mean, at least in this case here, right? So let's try to get the answer using the conventional method. Muhammad Ismail says he has got none of these, right? So we'll look at this, right? That seems to be a different answer. No one else has got this. So we'll try to solve this question using the conventional method first, the traditional method. How do you generally solve it? You write everything on paper and try to simplify. And then we'll look at a smart way of getting the answer, right? So let's quickly look at how do you generally solve it, right? 38.734 and then we say 8.638, right? So let's add these two values first, right? So what happens when you add 4 and 8, 12, this will give you 7, this is 13, 16 and 1, 17, and this is 4. So 47.372, yes or no? This is 12, you get 7 here, 13, 16 and 1, 17, and this will give 4. So 47.372 is the sum of the first two terms. Now from this sum, we need to subtract 5.19. That would give us an answer. So 47.372 minus 5.19. Minus 5. Be careful, you need to synchronize the decimal point in all the numbers. You cannot just take it in terms of left alignment or right alignment. Don't try to do that, right? So here we don't have any third digit. We can take it as 0. Now try to subtract 2 minus 0 is 0. 7 minus 9. 7 minus 9 is minus 2, but then that's not the right way to do the subtraction. I mean, this is very basics. I'm sure all of you understand this. So what do? We borrow 1 from 3. Yes or no? 7 minus 9 is giving us a negative value. So we borrow 1 from 3. We borrow 1 from 3 and then complete the calculation. So now it is 17 minus 9. What is 17 minus 9? 8. Then next 2 minus 1 is 1. Then the decimal there. 7 minus 5 is 2. 4 minus 0 is 4. So 42.182, which most of you have got it, right? 42.182. So good that all of you have got the right answer. 42.182. But then hold on, answer is correct, method is also correct, but if you really solve it this way, then you are wrong, right? This is not the right way to get the answer in a competitive exam like SBI clerks. You know that time management is very, very crucial in these exams, especially in bank exams where you get on an average 36 seconds per question, right? So do you really think that solving it this way will give you, that edge over the others? No, the competition is high, the competition is huge. You can't be wasting your precious time in doing all this nonsense. Just look at the amount of time that we have wasted here. Though we get the right answer, you first write the numbers, 38.734, 8.638. Writing these two numbers itself will take about 2 seconds. 2 seconds or, not less than 2 seconds, 2-3 seconds. Then you get the answer. Again, you will write that number, minus 5.19. So overall, 5, 6, 10 seconds, you just waste in writing down the numbers. Forget about the calculation part that you have done. Just in copying the numbers, we end up wasting about 5-8 seconds, which actually is a waste of time. Pure waste of time. So how can we avoid this? Look at the smart way of getting the answer. Instead of writing these numbers one upon the other, just try to do it directly, right? Don't write the numbers here. We'll follow the same technique. The technique remains the same, right? We add one by one the digits from right to left. Yes or no? From right to left. Always additions, subtractions, multiplications are done from right to left. So we add the digits one by one from right to left. That's what we are going to do in the smart way as well, but without having to write numbers on the paper. So let's see what can be done here. Instead of doing it in two parts, we can directly do in one step, in fact, right? So what do we do here? First add the last digits, right? You have got decimal numbers here. So first add the last digits, and then keep moving from right to left, right? But then look at this. Here we have got 3 digits after the decimal point, right? 3 digits. Here again after the decimal we have got 3 digits. But in this case 5.19, we have got just 2 digits after the decimal point. So remember, when you solve a question, a simple question like this one, you always have to balance the number of digits. So this becomes 5.190. That doesn't really change the number. We are just putting a 0 on the third position there. Now what happens? The addition and subtraction would be comfortable. It is convenient now because I can directly look at the third digits, second digits, first digit after decimal, and then units place, tens place, and so on. Right? So let's proceed now. Proceed with the solution. What do? Just focus on these digits, the third digits. 4 plus 8, 12. 12 minus 0. Take care of the sign here. It's 12 minus 0. 12 minus 0 is how much? 12. So we get 2 in the answer, and 1 gets carried forward. Like generally what do? 4 and 8 is 12, so 1 is getting carried forward. So take that 1 to the next position, right? 1 goes upon 3. You can take in this number or in this number anywhere, right? Anywhere. Not in this one, but on the first and the second one, right? Addition, right? So just take 1 on the first number there. Now, again, do a similar operation for the second digit, second digits there, right? So 1 plus 3, 4. 4 and 3, 7. 7 minus 9. 7 minus 9. Again, the same problem, right? 7 minus 9 is not possible here. So what do? We borrow 1 from the next place and try to make it 17. Are you able to follow? 1 is the carry here. 1 plus 3 gives you 4. 4 plus 3 is 7. 7 minus 9 is not possible. So we take 1 from 7. Let's make it 6, and this becomes 11. Are you able to follow? Make it 6. This becomes 11. You can take 1 here, or instead of taking on the carry, you take here 13. It doesn't matter. You can either take on 1 or you can take on 13. Ultimately, it's going to be increased by 10. So 1 plus 13 is 14. 14 plus 3, 17. 17 minus 9 is 8. So you get 8 here, right? 8. Now go for the next position. 6. Remember, it's 6 here, not 7. 6 plus 6, 12. 12 minus 1. 12 minus 1 is 11. So you get 1 in the answer, and now 1 gets carried forward. 1 gets carried forward, and here comes the decimal. Now look at the calculation, units place calculation. 1 and 8, 9. 9 and 8, 17. 17 minus 5, 12. Again, 2 in the answer, 1 gets carried forward. 1 plus 3, 4. Here we don't have a tens place. Here again we do not have any tens place. So 3 and 1, 4. 4 comes in the answer. 42.182, right? Maybe most of you have solved using this technique itself, but then those who have not done it in this way, those who have in fact followed this lengthy procedure, try to understand it's simply a waste of time. Though you get a right answer, you are not in the competition, you are not in the race if you follow this method. So keep it simple. technically both the methods are same. We have not done anything new. We are not doing different things. We are doing the same thing, but in a different way. Instead of writing the numbers and then adding and subtracting them, you take digit by digit and get the answer. Right? So that's about a very simple question from simplifications. And believe me, if you get 10 questions on simplifications, you can easily understand that about 2 or 3 questions maybe on these kind of calculations there, right? Simple additions and subtractions. Right? Let's move on to the next one now. There are other similar questions in the workbook here, but let's not take those ones. Let's quickly look at some other calculation, right? For example, this one, square root of 4356 into square root of the question mark divided by square root of 6084 equals to 11. We are required to find out what comes in place of question mark. 196 is the first option, then we have 125 followed by 169, 225, and the last option here is 81, right? 4356 into square root of question mark divided by 6084, square root of 6084 equals to 11. Simplify this and find out what comes in place of question mark. What comes in place of question mark? I think not more than 30 seconds. Appears to be complicated, but if you are aware of the smart way of getting square root, which you have already covered in the speed math sessions, how do you get square root of a number? It's a simple 3-step process. First step, find out the units place based on the pattern that we have in squares, right? Second step is to rule out the last 2 digits, cancel the last 2 digits, forget about the last 2 digits, find out the highest square less than the remaining part of the number, right? And that will give you the tens place. Now in the second step, you find 2 possible answers. Out of these 2, you can find out which one is correct in the third step by following the range. What can be the range of these numbers? So that's what you need to do. It won't take more than 3 to 4 seconds if you have really practiced on finding out square roots. So find out the square roots of these numbers quickly and then try to simplify. You will find out what comes in place of question mark. I think 30 seconds. Your time starts now. 13. We have got the first answer from Agarwal Nayan. He says 13 is the answer. Well, 13 is not in the options, and this makes me point out one of the most commonly committed mistakes in such questions. Now he has changed the answer. He says it's 169. 169. He has got 3 different answers. 69. I mean, are you giving me options, Nayan? Because there has to be only one correct answer here. You have given me 3 answers so far: 13, 169, and 69. And there's another answer coming in from Chandra, 144. How do you? I mean, all the 4 answers are different. Shashank says it's 144, and Bodepudi 22 has got 169. JC 72985 has got 169. Chandra has got well again, you see multiple answers from Chandra 982. 144 was the first answer, and now you say it's 169. So just zero into one of the answers. You can't be giving me 2, 3 different answers for such a simple question. All right. So let's solve this, right? Not really complicated. If you know the smart way of getting square roots, this won't take more than 30 seconds, right? What is the square root of 4356? What's the method that you follow? The number is ending in 6. So its square root will either end in 4 or in 6, right? Leave the last 2 digits. What is the highest square less than 43? The highest square less than 43 is 36. 36 is what? 6 square. So the tens place is going to be 6 here. 64 or 66. That's the second step. Now what's the third step? Find out which is correct. Is it 64 or 66? How do you do that? In between 64 and 66, we have 65. What is 65 square? 65 square will be 4225. Remember, how do you find out square root of? Square of a number ending in 5? When a number ends in 5, its square always ends in 25, right? How do you get the remaining part of the number? 6 into 7. 6 into the next digit, right? So 65 square will end in 25. The remaining part of the number will be 6 into 7, 42. So 4225. Now, if 65 square is 4225, this number here is more than 4225. So it's obvious that the square root should be more than 65. What is more than 65? 66. So this gives us 66 as the value. First part is 66. Root over question mark as it is. Likewise, try to find out the square root of 6084. The number ends in 4. So 2 or 8. Again, you don't really have to write those steps on paper. Just visualize and you'll be getting the right answer, right? So when a number ends in 4, its square root ends in 2 or 8. It's either ending in 2 or it ends in 8. Leave the last two digits. What is the highest square less than 60? 49. 49 gives you 7. 72 or 78. In between 72 and 78, we have 75. What is 75 square? 5625. This is more than 5625. So I can say 72 cannot be the answer. Answer has to be more than 75, which is 78. The other way to find out the correct answer is to look at the range. You know that the two possible answers are 72 and 78. 72 and 78 both fall between 70 and 80. What is 70 square? 4900. What is 80 square? 6400. Is this number closer to 4900 or closer to 6400? Closer to 6400. So answer has to be close to 80. Which is closer to 80? 72 or 78? 78. So both the ways you find that 78 is the correct value here, right? 78. Now you may get a doubt here. How do you know that the given numbers are perfect squares? Because if you remember, if you have gone through the speed maths video, the banker's choice speed maths video, which is for 4 hours, you would know that this 3-step process, this technique is applicable if and only if the given number is a perfect square. Here we are not really aware whether the number is a perfect square or not. So how do we do this? How do we decide whether it's perfect or not? Remember, simple logic or just take it for granted that when a question is asked under simplifications, just consider the number to be a perfect square. Do not really worry about it being a perfect square or not, right? Just assume that the given number is perfect square, solve, and you'll get the right answer. Because generally in simplifications, or I should say always in simplifications, imperfect squares are not asked. If it is about imperfect squares, that comes under approximations. And there is a different method, right? How do you find out the square root of a imperfect square? That's again a different method which we can learn from the approximations video of Banker's Choice online program. But here understand, always take it for granted that the given numbers are perfect squares. Now if you look at the question, this is 66 into root over question mark divided by 78 equals to 11. This goes 6 times, 6 here goes 13 times. Root over question mark is equal to 13. Root over question mark equals to 13. Now we are fortunate here, I would say, that in the options 13 is not given. If at all 13 was there in the options, I would say at least 20 to 30% of you would have marked 13 as the answer, because we are in a hurry. We want to get the answer as quickly as possible. We don't realize that this was square root of question mark. We feel that yes, question mark is 13 and mark the answer there, which I saw some of you commenting as 13, like Nayan Agarwal or someone, right? So same thing would happen in the exam. If not to Nayan Agarwal, it may happen to someone else, right? So avoid this. These are all silly mistakes which you need to be really careful about and avoid doing it in the exam. Getting the point, right? It's not question mark that is 13. It is square root of question mark, which is 13. Now when you square on both the sides, it is 169. So the correct answer here is option 3, 169. Right? So not really a method here, but what I was trying to focus on is finding out the square root. If you are good in finding out the square root, if you can really do that in 2-3 seconds, this question I would say would take about 10 to 15 seconds maximum for you to get the required answer. If you are not clear on how to find out square roots, then better leave it, because there's no point in following the actual procedure, the traditional procedure to find out the square root and then find out the required answer, right? So learn all those speed maths techniques which we have discussed in the previous speed math sessions through these live sessions, or you can also watch the Banker's Choice speed maths video, which is for 4 hours, where we have got 16 different parts. This is one of those parts. Finding out square root is one of those 16 parts, right? But then there are various other techniques which can be helpful for multiplications and other sorts of arithmetic operations, right? So speed maths is really going to be a very important companion for you to get the answers fast, right? So let's now, I would say it's all about how quickly you look at these, how quickly do you solve them. Now let's look at this one interesting question. It says question mark squared plus 65 squared equals to 160 squared minus 90 squared minus 7191. The options given are 75, 77, 79, 81, and the fifth option is none of these. The fifth option here is none of this. And I would like to give you one more question. Let's see. 342 divided by 6 into 28 equals to 1099 plus what? All are simple bodmas base questions. You just have to follow that rule, simplify, and you'll get the answers. The options here are 478, 502, 486, 504, and fifth option is none of these. Fifth option is none of this, right? So 342 divided by 6 into 28 equals to 1099 plus question mark. 478, 502, 486, 504, none of this. I think 1 minute should be more than sufficient. Ideally, I would say it shouldn't take more than 20 seconds to answer these two questions, but maybe because you're doing it for the first time, I'll give you 1 minute. Your time starts now. क्या मेरे पास मैनेजर लोग हैं. All right. So seems like some of you have got the answer, right? I see first answer coming from Nayan Agarwal. None, he says. Praveen has got 78. And K. Jhansi.Rani has got 78. Dipanjan has got 79. Sautrik says it's second question. The answer is 497. He says 497. All right. Padmalakshmi has got 78. Nayan says for both the questions the answer is none. Okay. Ramana has got answer as none for the second one. And Varsha Chaurasi has got 78. All right. Any more answers there? Right. Praveen says the second one should be 497. Pradeep Sarkar says it should be 81. 81 for the first one. Okay. And none of these for the first one also. Shashank has got none for the first one and second one both. All right. So seems like good number of answers. You all have solved it. But then there is a catch here, right? 78. 78 is the answer which you have given for the first question. Not all of you, but most of you have said that the answer is 78. And I really don't know what is the answer others have got. Others all are saying that it is none of this, but what is none of this? Is it 78, or as in, have you got 78 and then you are saying because 78 is not there, it is none of this, or directly you have got none of this as the answer? See, what I'm trying to tell you here is that 78 may be the right answer for this one. But then those who all have got 78, those who have solved it to get 78, have simply wasted their precious time. I know question appears to be, lengthy, but then simple calculation. 65 square will be how much? 6 7 is 42, so 4225. 160 square, 16 square 256. So this will be 25,600. 90 square is 8,100, and 7191 as it is. So you can just do that calculation to arrive at the right answer, which may be 78. I mean, you'll get some value. You have to take the square root of that to find out question mark. 78 may be the right answer, but then that's not the right approach, because this question can actually be answered without doing any of these calculations in a smart way. Now, what I'm going to explain here is called units digit method, units place method, which I'm sure most of you are aware of. What do you mean by this units place method, or what actually happens here? See, try to understand. Let's say there is a number which ends in 3. There is some 4-digit number which ends in 3, and there's another number which ends in 5. Right? What will be the sum of these two numbers? I may not be aware of the remaining digits, but I can surely say that the units place is going to be 8. Yes or no? One number ends in 3, the other number ends in 5. So when you add these two values, the answer will end in 8. That is for sure, right? Because when you go for traditional addition also, we first add the unit places. So 3 plus 5, 8. What is the remaining part? We are not worried about, but it should be ending in 8. Likewise, let's say there is one number which ends in 6 and the other number ends in 1. What will be the difference? The difference ends in 5. Yes or no? The difference here will end in 5. 6 minus 1. Only look at the unit place. Don't worry about the remaining part. 5. Or maybe if this number is lesser, you will get 1 minus 6, 4. Right? I mean, that again depends, but generally 6 minus 1 is 5. Likewise, multiplication. One number ends in 4 and the other number ends in, let's say, 3. What will be the product ending in? You know that in multiplication again we add the unit spaces first. So 4 into 3 is 12. 2 in the answer in the unit place. 1 gets carried forward to the tens place. So 2. So I can say that when one number ends in 4, the other number ends in 3, the product would end in 2. Likewise, if one number ends in 6, the other number ends in let's say 3. 6 into 3 is 18. So their product will end in 8. So this logic is what will help you answer some of the questions much faster. Right? Now, what questions? It again depends on the type of question, the type of options there, right? But try to understand that units place method is what we have understood here, right? This is the logic that we are going to use. Only based on the unit spaces, you will try to find out what can be the possible answer or what are the wrong answers. If not the right answer, you will at least be able to find out which 3 are wrong or which 2 of them are wrong, right? Simply addition, subtraction, and the multiplication of the last places. But one very important point which I would like to mention here is that this particular technique, this units place method, does not hold true for division. That is, if one number ends in let's say 8 and the other number ends in 4, can you tell me what will be the answer ending in? There's one 4 or 5 digit number that ends in 8. The unit place is 8. There's, let's say, some 2 digit number or 3 digit number which ends in 4. And dividing these two values, what will be the answer ending in? What is 8 by 4? 8 by 4 is 2. So can you say the answer ends in 2? No. Remember, this units place method does not work for divisions. It works for multiplication, additions, and subtractions, but not for divisions. Right here, it cannot be determined. You cannot determine what is going to be the unit space in case of divisions. Why does this happen now? Why can't we apply this for division? Because understand, division is not a digit by digit operation. For example, if there is a 3-digit number which is to be added to another 3-digit number, we first add the unit spaces, then we add the tens places, then we add hundreds places, and so on. Likewise, subtraction in a similar way. First unit place, then tens place, then hundreds place. Multiplication also in one way is a similar operation, right? You do a digit by digit operation. First unit space is multiplied by unit space, then unit space with tens place, unit space with hundreds place, and so on. But does that happen in division? For example, I have to divide, let's say I have to divide 528 by 14. So do I divide 8 by 4 first, then 8 by 1, 2 by 4, 2 by 1, 5 by 4, 5 by 4? No. In division, we take the number as a whole. The complete 14 divides the complete 528. The whole of 14 divides the whole of 528. Right? So here, you really cannot work on these unit spaces, 8 by 4, 2. That's not the idea here, right? Unit space does not work when it comes to division. So just keep this in mind and see how can we apply this for some questions. Again, it depends. It depends on what? It depends on the options. Mostly it depends on what kind of options are given to you. For example, if you look at the first question here, Simple, not really difficult. If you do the complete calculation also, you'll get the right answer, 78, which most of you have got. 78 is the right answer. But then just look at the options, 75, 77, 79, 81, none of this. What I observe here is all the options are ending in different unit spaces. None of this anyway is not known to us, but then 5, 7, 9, 1. So if at all I am able to work out on the unit space of the question mark, if I am able to decide what will be the unit space of the question mark, I will be able to mark the answer directly. Avoid none of this for some time. Just look at the first four options. Now you may wonder, how do we avoid none of this? Even none of this may be correct. Yes, you are right. None of this may be correct. But then, if at all, let's say in the exam, fifth option is also given as some value, then you can obviously go for the unit space method instead of doing the complete calculation. Right? Let's look at this. Let's look at this. So how do we do it really? Look at the calculation. This question mark square has to be anyway calculated, or question mark has to be calculated. When a number ends in 5, its square also ends in 5. When any number ends in 5, its square ends in 5. So can I say the number here will be ending in 5? Forget about the remaining part. Number ends in 5 equals to 160 square. When a number ends in 0, its square also ends in 0. So there is some number here which ends in 0. Minus 90 square, another number which ends in 0. In fact, this is 8100. Don't worry about that. Number will end in 0. Minus the last part, 7191. This is ending in 1. The number itself is given to us, right? It ends in 1. Now, if you try to work on only on the unit spaces, 0 minus 0. 0 minus 0 is 0. 0 minus 1. Now, 0 minus 1 is minus 1. But understand, friends, when you're doing a subtraction, if it is 0 minus 1, what do? We borrow 1 from the next place. That's what we have seen in the previous two questions, or the previous question which was based on addition and subtraction. What do? We borrow 1 from the next place, tens place, and make it higher than the next the value to be subtracted, so that we can get a positive digit here, right? So 0 minus 0 is 0. 0 minus 1, don't write minus 1. 0 minus 1 is not possible. Not possible as in these are digits here of some number. So we borrow 1, that 0 becomes 10. 10 minus 1, 9. So now I can say that the right hand side ends in what? It ends in 9. The right hand side ends in 9. Some number, it ends in 9. Equals to, look at this part now. Something which ends in 5 plus question mark square. Now try to balance the unit spaces. What happens? 5 plus what will give you 9? 5, what should come here in the unit space so that you get 9 there? 5 plus 4. So clearly, now I know that the question mark square should be ending in 4. Are you able to follow? This 4 plus that 5 will make it 9. Balanced on both the sides. Question mark square ends in 4. Now tell me, when a square ends in 4, this is a square. When a square ends in 4, its square root will end in what? Either 2 or 8. Yes or no? When a number ends in 4, its square root. We are required to find out what comes in place of question mark. So we have to apply square root, right? So square root will either end in 2 or it ends in 8. That's it. What I know is question mark should either end in 2 or in 8. Look at the options. First option, 75. Not possible. It should either end in 2 or 8. 77, not possible. 79 is not possible. 81 is not possible. I am 100% sure that fifth option, none of this is the correct answer. Even you are right. Those who all have got 78 are also correct. But then look at that. You have done the complete calculation to get the answer 78. But is that required? No. And because I was trying to explain you, it has taken so much of time. If you really understand the concept and apply it yourself, it would take what? 10 seconds? 10 seconds at the max, right? And you get the right answer, right? But again, I would say there is a limitation, right? Here you may see that all the first 4 options are getting ruled out. So fifth option, none of this. But let's say only 3 of them get ruled out. If one of the answers is ending in 2 or 8, then again there's a dilemma. Either the answer may be that 78 or it may be none of this. Right? For example, let's say instead of 79, I have 78. Now what happens? First one, second one, and third one are ruled out. The answer may either be third option. First, second, and fourth one are ruled out. The answer may either be third option or it may be fifth option, because this satisfies the condition. Our condition is that the answer should be ending in 2 or 8. So either 78 is the answer or none of this is the answer. So in this case, maybe it doesn't really help. But understand, there may be some questions or there may be a certain situation in the exam where you'll have to take some chance. You'll have to take a risk. For example, let's say you're solving this question in the last 5 minutes of your exam. You want to do as much as you can. I mean, actually your speed should be the same from the beginning, but generally last 5 minutes we want to just make sure that we run through all the questions. So in such a situation, when you already know that first, second, and fourth one are wrong, I would say you take a chance and mark 78 as the correct answer. Do not do not wait to do the complete calculation. That would take what? Again 30 seconds, 45 seconds, which will give you the correct answer, but then 45 seconds for correct 1 mark, or 5 seconds for a 50-50 chances of getting 1 mark. Because understand, we are not making a blind guess here. I am 100% sure that first one, second one, and fourth one are wrong. Either 3 or 5. So 50-50 chance that your answer will be correct. Either mark 78, or if you want to go for none of this, you can go for another example. It depends again. I don't say that this is really a right method to get the correct answer, but then at least you are able to cancel out some of the answer options. Or if the question is really complicated, where going by the actual procedure takes you a lot of time, you can take such chances and mark the answer there, right? But also remember, you have to be ready to go wrong. Your answer may be wrong. Suppose in this situation, if I mark 78, the answer may be 72. Who knows? The correct answer may be 72. I should be ready to take that minus 0.25, because if it goes wrong, my answer will be minus 0.25. I mean, I'll get what? Minus 0.25. If it is correct, I'll get plus 1. So this clarity you need to have before you apply this. Otherwise, the only way is to do the complete solution. So it is you who has to decide what you want to do in such questions. Let's quickly look at the next one as well, right? Similarly, the next one. So this is called as unit space method, which I'm sure you can apply. Now, a similar unit space method can also be applied for this question, right? For example, 342 by 6 into 28 equals to 1099 plus question mark. 1099 plus question mark. What do you do? What is 342 by 6? 300 by 6, 50. 42 by 6, 7. 50 plus 7, 57. So no, 342 by 6 is 57. Anyway, we have to do division. So this is 57. So 57 into 28 equals to 1099 plus what? Now, ideally, if you have to follow the procedure there, what do we do? Multiply 57 into 28, then subtract 1099. 57 into 28 minus 1099 will give you the required answer. But before you do that, I would say quickly look at unit space method. I mean, can you really go for it? And that depends on the options. 8, 2, 6, 4. So there is a chance that I'll be able to eliminate, if not all the 4, at least 3 options, because unit space will be any one of them which will be able to decide. Here, all the unit spaces are different. So I'm really okay by following unit space method here, right? So what do you do? Instead of multiplying 57 with 28 and then subtracting 1099, try to balance the unit space. 7 into 8. One number ends in 7, the other ends in 8. What happens? The product ends in 6. 7 into 8, 56. So the answer ends in 6. So I know that the left hand side ends in 6. The left hand side ends in 6. Look at the right hand side. One number ends in 9, 1099. So this number ends in 9. Plus what? Plus what is the question mark? I mean, what is the question here? What comes in place of question mark? Now try to understand. 9 plus what can give you 6? I mean, 9 plus anything will not give you 6, but here it's a digit calculation, right? 9 plus something will be definitely more than 9. But 9 plus what may give you 16, so that 1 gets carried forward or 2 gets carried forward. That's the logic. 9 plus 7. What is 9 plus 7? 16. So I get 16 the answer. 1 gets carried forward. Or 9 plus 17. 9 plus 17 is how much? 26. So I get 6 in the answer, 2 gets carried forward. So clearly, the units place of the question mark should be 7. This value should be ending in 7. Look at the options. Not possible. Fifth option, none of this. Are you able to follow? Here, answer has to end with 7. 9 plus 7, 16. 6 is the answer there. I mean, 6 is the unit space. So again, I can say fifth option, none of this is the answer. Now, you might be wondering, you might be thinking that intentionally we have given the options in such a way that only one option, fifth option, none of this satisfies. Because I have given this question, right? So you may be thinking that I have prepared the question in such a way that only one of the options satisfies. Believe me, these are the previous SBI clerks exam questions, copied as it is. Are you able to follow? These questions which you have taken, the previous 2 questions, the previous one and this one, are as it is taken from the last year's or one of the previous year's SBI clerks exam papers. So there are chances that you may get questions in such a way that without doing the calculation, you will be able to mark the right answer. Are you able to follow? So just try to follow this. You may not be able to apply this always. If all the answers are ending in 7, you will get the. I mean, if all the answers are ending 7, this technique doesn't work. So there is no need to apply in that kind of situation, right? Only depending on the options, you'll have to just take a call, right? So that's about unit space method. There are more questions that we can take, but I think I'll just quickly move to the next technique there. JC72985 says it's 4 not 6. What is 4 and not 6? I think just I don't know what is the context there. Some comment there which says it's 4 but not 6. Just try to watch it again. I'm sure you'll be able to follow that. Now let's quickly move on to. I really don't have enough time now. I wish I could solve more number of questions from each of these techniques, but last 5 minutes I'll try to explain you something called as digital root, right, or root digit method. This again is useful in answering certain questions from simplifications, but not really preferred. If you ask me, I would say better go for unit space method than going for root digit method. This is not known to many of us, but then it is somehow helpful in answering some of the questions, right? So I'll just quickly explain. I wish I had more time so that I can interact more and solve more number of questions, but anyway, let's look at this one. So what I'm going to explain you now is a concept called digital root. Digital root, or it's called lucky digit by some people, or you can call it as root digit. Anything is okay, right? Digital. What do you mean by digital root, by the way? Digital root or the root digit of a number. See, this is very simple. In any given number, if you keep adding the digits till you arrive at a single digit number, that is what is called as the digital root or the root digit. Right? Generally, this is followed when you go for a registration. Let's say you are going for a vehicle registration. So people have this superstition or what. I mean, someone who believes in numerology. He says 7 is my lucky number. So all the 4 digits should add up to 7. So that's what is called as digital root, right? So directly or indirectly, I mean, you know about this concept, but let's see how do we apply this. Let's quickly look at some examples to understand what is meant by digital root. For example, the number here is 4589276. What is the digital root of this number? What is the root digit of this number? What do? Keep adding the digits till you get a single digit number. 4 plus 5, 9, 9 plus 8, 17, 17 plus 9, 26, plus 2, 28, plus 7, 35, plus 6, 41. 41. If you add all the digits, you are getting 41. Again, add the 2 digits in 41 because we have to arrive at the single digit number. 4 plus 1, 5. So I can say the root digit number is 5 here. The root digit here is 5. Right? For example, let's say the number is 7178. What will be the root digit? 7 plus 1, 8, 8 and 7, 15, 15 and 8, 23. So 2 plus 3, again 5. I mean, it does not mean that always it is 5, just a coincidence that we have got 5 in both the cases, right? Let's say if it is 6954, then what happens? 6 plus 9, 15, 5, 20, plus 4, 24. 2 plus 4, 6. If it is a 2-digit number, let's say the 2-digit number is 29. What happens? 2 plus 9, 11. 1 plus 1, 2. So the root digit. So this is what is meant by root digit, right? Now, before we look at some questions, one important point which I would like to mention, right? I would like to draw your attention to one very important point here. Look at this. As per this concept actually comes from Vedic mathematics, and as per our ancient Indian mathematics, 9 is a very powerful digit. I mean, 9 in one way is the most powerful digit, right? 9 is the most powerful digit. Now, we will not be discussing the detail behind that, but understand what I try to mean here is in finding out the root digit, whenever you find any of the digits as 9, you can neglect it. That will not affect your root digit. That will not affect your digital root. And not only 9, if there are 2 digits which are making a total of 9, you can neglect those digits. Are you able to follow? Like 8 and 1, 8 plus 1 is 9, right? So in a given number, if you find both 8 and 1, rule, cancel out both 8 and 1. That is not going to affect your root digit. If it is 9, cancel that. If it is 6 and 3, cancel that. You'll get the final same answer. For example, here, if you look at this number, 9 gets cancelled, 4 and 5 is 9, so leave it, 7 and 2 is 9, leave it. Only look at the remaining digits there. 8 plus 6 is 14, 1 plus 4, 5, the same root digit, yes or no? Or if you're really smart, what you can do, instead of adding 8 and 6, just give 1 from 6 to 8, that becomes 9. Even that gets cancelled. What is left out? 5. That's your root digit. Right? Likewise, the other numbers. Here you see 1 and 8 gets cancelled. 7 and 7, 14. 14 is what? 5. Root digit is 5. 1 plus 4, 5. Here 6, 9, 5, 4. 5, 4, 9 gets cancelled. 6 is the root digit. Look at this one. 2, 9, 29. 9 gets cancelled. 2 itself is the root digit. So this is how you can calculate the root digit faster, right? Let's now understand the application of this. What is the use of finding out the root digit, right? How does it really help us in getting the answer? I would take a simple question, in fact, or let's take a simple example. 23 into 41 is equal to what? 23 into 41 is equal to what? That's the question, let's say. And some options are given to you. I'm just taking a very simple example. Then we'll take one more example from the workbook. And with that, I think I'll be done and I can close the session. So 23 into 41. What is 23 into 41? How do you multiply? Don't start doing this. 2, 3, 4, 1, 3, 1s are 3, 1, 2 is 2. This drama is not required, right? Oral calculation, mental calculation. You have learned this in the speed maths video, right? 23 into 41. Take it 40 times, then take it one time. What is 23 into 4? 92. So 23 into 40 will be 920. Then 23 into 1 will be 23. 920 plus 23 will be 943. So the answer here has to be 943. Yes or no? Or 41 taken 23 times. 41 taken 20 times, 820. 41 taken 3 times, 123. 820 and 123 will be 943. So the answer is correct, 943. Now, the point which I'm trying to make here is that not only the multiplication, but also the multiplication, not only the multiplication of the numbers here, but also the multiplication of the root digits will be balanced on both the sides. As per Vedic mathematics, an equation should always be balanced in terms of its root digit. It is always balanced in terms of its digital root or root digit there. So whatever is the root digit on the left hand side, same will be the root digit on the right hand side. For example, the number here is 943. The answer is 943. What is the root digit of 943? 9 is gone. 4 plus 3, 7. If the right hand side, the root digit is 7, understand, when you simplify, the root digit on the left hand side should also be 7, right? How do we simplify that? Look at this. What's the root digit of 23? Root digit of 23 is 5. 2 plus 2, 2 plus 3 is 5. Root digit of 41 is also 5. 5. Now, what's the operation in between 23 and 41? It's multiplication. What is 5 into 5? Multiply the root digits. 5 into 5, 25. 25. What's the root digit of 25? 2 plus 5, 7. Balanced. That's the idea. Very powerful, but then I would say a little complicated. Not complicated, but time consuming, because when it comes to unit digit method, we can quickly add the unit places and get it. But in case of root digit, you have to add all the digits, you have to keep adding it till you get a single digit number, and then you have to check in every of the options, each of the options, right? How do you really apply 23 into 41 equals to what? Options are given: 943, 782, 645, 921, and so on. Find out the root digit. You got the root digit of left hand side as 7. Check in the options. Whichever option has got root digit as 7, that is going to be your answer. You don't have to do the actual multiplication. But I would say in such a simple case, doing the actual multiplication is better than finding out the root digit, because by any chance, if fifth option is the answer, 943 is given in fifth option, then you have to find out the root digit of first 4 options. Each one will take at least 1 second, 2 seconds, 8 seconds are gone in that. And in 4 seconds, we'll actually get the right answer. So application is there. There is an application, you can find out the answer, but then you have to apply it carefully. You just can't be applying it to every question given there and check what is the root digit. It will anyway give you the right answer, but then not really helpful, because time is what is our concern. It's not the answer that we are looking for. It's we are looking for a quick answer. How quickly can you get the right answer? I would take one question from our material on from our banker choice workbook on this, and then I think I can close the session. And it's practice after that, right? What I've done here is 10%. 10%. I've only shown you what kind of techniques you can apply. Some of the techniques that you can apply, right? There are other techniques as well, but then these techniques, if you practice more and more, right? If you keep practicing on them till you go for the exam there, you will really find a dramatic change in your speed maths and in your simplifications ability, right? So keep practicing. Practice is the key, right? Knowing the method is not important. Applying it is important. You must be able to apply it comfortably, conveniently, without wasting much of your time. So just one question on root digit, and then I think we can go for the close of this session, right? 43 square plus 841 equals to what square plus 1465? The options are 15, 65, 45, 35, and 25. 15, 65, 45, 35, 25. The question says 43 square plus 841 equals to what square plus 1465. Now if you really understand, solving this doesn't really take much time. What is 43 square? How do you find out square of a number? Always take the base as 50. So 50 minus 7. 50 minus 7 whole square. So 2500 minus 700, 1800 plus 7 square 49. This is 1849. 1849 plus 841 equals to what square plus 1465. Again, add, subtract this value, take the square root, you'll get the answer, right? But instead of doing that, let's check if root digit really helps. How do you find out the root digit is already known to us, right? What is the root digit of 841? 8 and 1 is gone. Root digit is 4. Plus, look at this calculation. This is 43 into 43. 43 square is nothing but 43 into 43. What is the root digit of 43? 7. 7 into 7. Understand, 43's root digit is 7. 4 plus 3, 7. 7 into 7, 49. Root digit will be, the number there will be 49. Again, root digit of that, you have to always take the single digit number. So 4 plus 9, 13, 1 plus 3 is 4. Or leave the 9 there, you directly get 4. So the root digit of 43 square is going to be how much? 4. Are you able to follow? 43 square, 43 into 43, 7 into 7, 49. That gives you 4. So 4 plus 4. My left hand side root digit is 8. 4 plus 4. Do a similar operation. If it is plus here, plus always. So 4 plus 4 is 8. Then look at the right hand side. 1465. What's the root digit here? 6 and 5. 4 and 5 gets cancelled. 1 plus 6 is 7. Plus question mark square. Now understand, 8 equals to some question mark square plus 7. What should be the root digit of question mark square? It should be 1. Root digit of question mark square should be 1. That 1 plus 7 will give you 8. That's it. Now check from the options. Which number, when placed in place of question mark, will give you 1 as a root digit. And be careful, this is square. This is not simply question mark. This is square. Now how do you check that? I want the answer's root digit to be 1, right? Now if you look at the first option, 15. 15 square. 15 into 15, right? What is the root digit of 15? 6. Now 6 into 6. Here it will be 6 into 6. Be careful. Don't check 6 and say 6 plus 7 is not balanced. 6 into 6 is how much? 36. 36 is what? 3 plus 6, 9. I want 1. Root digit to be 1. This gets eliminated. 65. What's the root digit of 65? 6 plus 5. 11. 11 is 2. 1 plus 1, 2. 2. 2 into 2. 2 into 2 is what? 4. But 4 plus 7 is not 8. So this gets eliminated. 4 and 5, the root digit is 9. And understand, when the root digit is 9, any kind of operation you do, square, cube, it's always going to result in 9 only, right? 9 into 9, 81. 8 plus 1, 9. So this will be 9. But 9 plus 7 is not that, right? 35. What is the root digit of 35? 3 plus 5 is 8. 8 into 8. 8 into 8, 64. 6 plus 4 is what? 10. 1 plus 0, 1. 1. Root digit is 1. 1 plus 7, 8. Balanced. Maybe this is the correct answer. But again, it depends on the next option here. 25. 25. 2 plus 5, 7. 7 into 7, 49. Root digit is 4. 4 plus 7 doesn't balance. 35 is the answer. Only option left out here is 35. That has to be taken as a correct answer. But again, is it applicable always? Applicable in every equation. Understand, root digit should be balanced. Always it gets balanced. The digital root always gets balanced. But the point here is, it depends on the options given to you. For example, what's the root digit of 35? It's 8 actually. So if at all the options are 8, root digit is 8, then gone. For example, let's say fifth option is given as 53. If 35 root digit is 8, 53 is also 8. 8 into 8, 64. 6 plus 4, 10. 1 plus 0, 1. This will also, seem to be correct. If it is given as, let's say, 62. What's the root digit of 62? 8. 6 plus 2, 8. 8 into 8, 64. 6 plus 4, 10. 1 plus 0, 1. So the point here is like unit place method. It's not applicable always. It depends on the options there. There you can easily identify, can you apply or not, based on the options, unit spaces. But here it will be difficult, right? It will not be difficult, but then more time consuming compared to unit space method. So the idea here is, though it's easy, interesting, and it's applicable, you don't have to apply it always. Only when unit space method fails, you go for root digit method. And that may sometimes give you two possible answers, 53, 35, both are possible. Then maybe you'll have to go for further calculation, or you have to do an approximate calculation and get an idea. And there are other techniques again, approximations. Approximations sometimes will give you a quicker answer, right? But then I don't think I'll be able to discuss that. It's already 10 minutes above the scheduled time. So I'll close the session here. I wish I could do more, but then this is what you need to stick to: unit place method, digital root method, and more than that, how quickly you do these simple calculations, right? So follow the speed maths video. You know that actual speed maths video in the Banker's Choice online course is for 4 hours, which has got 16 different parts. So if you go through that complete speed math video, you learn a lot of different techniques and methods of doing these calculations. And when you practice on them, you yourself will discover more and more ideas. So speed maths is what you need to understand properly, and you must be able to apply that properly. And then more practice. I would say this is more of practice. The more you practice, the easier it gets. The quicker you will be able to get the answers in the exam, right? So just keep practicing. Remember, practice is the shortcut. There is no other shortcut. It's more of your practice. Knowing the method is not important. To be able to apply that in the exam, to be able to apply that at the right place in the right time is what is important, right? So just keep practicing. All the best for your exam. I hope all of you do well. And I also hope that you have enjoyed this session. Please share your valuable feedback on this live session here, and see you in the next session. Our next session is scheduled on 2nd of July at 6 p.m. where our senior faculty, Ms. Sylvia Fiona, will share a very important idea with you. That is how to prepare a killer resume. Whatever be your stream, whether you are an IT guy or you want to get into banking, or you apply for any kind of job, something that is very important, a tool that is very important in selling yourself is your resume. So she will be covering on how to prepare a resume that stands out, right? That stands out and it's different from others, right? Different from others. It can help you improve your chances of getting that job, right? So don't forget to join us on 2nd of July at 6 p.m. for the session on how to prepare a killer resume, right? Keep practicing. Thank you. Thank you for joining us.